Hello everybody, welcome to my another video in which I try to explain physics as simply as possible but not simpler. And here is another problem related to the uniform motion and, as you can see, also to analyzing some graphs. So the problem is inspired by the problem from the Polish textbook. The name of the book is in the description, and also the full text of this problem is written in the description of the video, but I will read it for you. So the object was moving in a straight line along the x-axis. This figure shows a graph of the dependence of the position x of this object on time t. And our first task is to describe how an object was moving in different time intervals. Okay, so look, this is distance x in position x in meters versus time t in seconds. Okay, so you can see that the object starts at the position +1 and it moves like this and like this. So from 0 to 4 seconds we have a straight line, linear dependence of x on t. So this means that this is the uniform motion, so motion with constant speed. How do I know this? How can I prove this? So you know that in the uniform motion, speed is distance divided by time, and distance can be thought of as the change in x, so final x minus initial x. Okay, and I want to have x in terms of t, so I want to have x equals something, so I multiply both sides of the equation by t, so I have vt equals x minus x0, and then I move x0 to the left, so I have vt plus x0 equals x. So x, if you just interchange the sides of the equation, x is vt plus x0. So this is x of t. Let's think of it as a function. I hope you know some basics of functions from maths. So maybe you are familiar with linear functions. So y of x as ax plus b. So look, this has exactly the same form, this equation. So you can argue that if x is a linear function of t, that comes from this equation, which is related to the uniform motion. So this is how I know that if I have the graph that the position is linear function of time, then it should be the uniform motion. So from 0 to 4 seconds you have uniform motion. Then from 4 to 6, look, the position doesn't change, it's still 5 meters. So it means that this object just doesn't move in this time interval. And then from 6 to 12, again it's a straight line, so again uniform motion, so it's again uniform motion, but the function is decreasing. What does it mean? It just means the object is going the opposite direction. How do I know this? Again, it's not illumination, you can see this. Let's draw just the x-axis, x in meters, 0, 1, 2, 3, 4, 5, and -1 here. So this is like project this onto x-axis. So you see our object starts from position 1, and in first 4 seconds it moves to position 5, then it just stays here for 2 seconds, and then it moves in a way that x decreases from 5 to 4, 3, and so on. So how can I draw that x decreases? You just move this direction, right? And you stop at -1. So it's no magic with this -1. This is just where you you just decide where on your axis is 0. Okay, so this is how it looks like. Okay, what else we are supposed to do here? Calculate the distance traveled by the object from 0 to the end of the 12th second of motion, so in this whole time period. Okay, so distance will be okay, so first it covers 4 meters. You can see that there are 4 units, or you can calculate it as absolute value of the final position 5 minus initial position 1, and then this part. So final position is -1 minus initial position 5, and so this is 4, and also there are 4 units, and this is 6 because it's absolute value of -6, and you can easily see that these are 6 units, so this is 4 plus 6, so the total distance of the object is 10 meters. Okay, next, specify the displacement of the object at the same time. So displacement is how it moved from initial to final point. So that's this, okay? That's this from start to end. So you can think of it as the change in x. And you can just see that, of course, these are 2 meters, or if you want, you can say final position minus very initial position. So anyway, it's 2 meters. Okay? Next, calculate the average speed of the object in this motion. So again, as in the problem with the tourist, which I discussed in one of my previous videos, average speed is total distance divided by total time. So total distance is 10 meters, as we calculated here. Total time is 12 seconds. So it's 10 divided by 12, and if you use calculator, you get that this is approximately 0.83 meters per second. Okay, next, draw a graph of the distance s of this object versus time t. Okay, so look, we need to distinguish position, so this is where the object is, distinguish it from the distance, so how long distance it covered. I cannot find other words to express this, so let's see. It will be easier for us if we draw it one below another. So here, vertical axis is distance s in meters, and the horizontal axis time t in seconds. So here is 0, and I know that I will need more, so here is 2, 4, 6, 8, here is 10, okay? And let's keep the same scale, time scale, so that we can benefit from the plot above, from the graph above. So in the beginning the distance is 0, but position was 1, okay? And in the first 4 seconds the object traveled 4 meters, okay? So after 4 seconds the distance is 4 meters, like this. From time 4 to 6 it doesn't move, so the distance didn't change, and from 6 to 12 it covered 6 meters, so okay, so it changes from 4 to 10, so it looks like this, okay? And the last part, draw a graph of the speed v of this object versus time t. So again, let's draw it below. Time t in seconds, and here is speed v in meters per second. And let's see what scale we need, because we need to do a little bit of calculations. So from 0 to 4 seconds, that's the first interval, so let's call it v1, and we know that this is uniform motion, so we calculate speed from the known formula distance over time. And you know distance in this 4 seconds is 4 meters, so you have 4 over 4, so it's 1 meter per second. From 4 to 6 it doesn't move, so speed is 0. From 6 to 12 seconds speed, so its third interval, is also calculated as, or better, let's think of it, the distance may be better, think of it as change in x over t, okay? Because here we can say that change in x is -1 minus 5, so final position minus initial position, divided by 4. If you do it here, nothing changes, because here is 5 minus 1, so it's 4, everything is fine. But here let's do it like this. Oh, time is 6 seconds, because it's from 6 to 12, so you have -6 over 6, so this is -1 meter per second. What the hell, -1 speed? That's big. So this minus tells you that you are going opposite direction. Here is positive speed, which means this direction, minus means that direction. So you see that the x values grow in this direction. So if you if the speed is along the same as growing, x is positive. It's if you go towards smaller values of x, the speed is negative. That makes some sense. Okay, so we know what we need. Here is 4 seconds, 6 seconds, here is 12. So you need speeds +1 and -1. So here is 0, here is +1, here is -1. Okay, so from 0 to 4 it's uniform motion, so speed doesn't change, it's all the time 1 meter per second, like this. Okay, then it's 0 over here, and then it's -1 from 6 to 12. So this is how the graph looks like, and that's all in this problem. And it was also the last problem about the uniform motion. So now I suggest you to move to my videos about accelerated motion, so uniformly accelerated and uniformly decelerated motions, where I explain them and I also solve some problems related to them. Thanks for your attention, and please ask questions in comments if any.